we're going to take a look at some examples of how to actually use the 6 basic trigonometric functions to solve a right triangle, which is the terminology often used. And we're also going to take a look at some applications of how to use those particular functions to solve real world type scenarios. So let's begin. The instructions would read: use Pythagorean theorem to find the length of the missing side, then find the value of the 6 trigonometric functions. And the intent of this particular type problem is really just to get you familiar with those 6 basic trigonometric functions. But in order to do that, we need to know the third side of our triangle. Now, we do have here, it may not be as obvious, but we do have a right triangle. Here is our right angle. Okay, and opposite that right angle would be our hypotenuse, which is the side that I do not know. And so I have the side, the angle, which is my point of reference, which is theta, is in this kind of this bottom corner, if that's what you want to think about it. So the side that has a length of 6 is opposite that angle, and the side that has a length of 8 is adjacent to that angle. And so that may help me out a little bit later as I start setting up those relationships. But those two legs together, I need to first find the length of the hypotenuse using Pythagorean theorem. A squared plus b squared equals c squared. So I have 6 squared plus 8 squared equals c squared. That's 36 plus 64 equals c squared. C squared equals 100. I'm then going to take the square root of both sides to find just plain old c. So c equals positive 10. So the length of my hypotenuse in this particular scenario is 10. Once I have determined the hypotenuse, I then want to find my 6 trig functions. It doesn't matter which one you begin with. We tend to start with sine. So sine of theta is opposite over the hypotenuse. So we would have 6 over 10, which, guys, is a fraction, and you should always simplify a fraction. So 6/10 simplifies to 3/5. Then if we look at cosine, the cosine of theta equals the adjacent over the hypotenuse. And notice how I write out the kind of the formula each time. I've also labeled the triangle. I just think that's helpful. So we would have 8 over 10 simplified is 4/5. We always simplify fractions. Third, we would have tangent. Again, the order that you do them in really doesn't matter. Tangent of theta is opposite over adjacent. Okay, and that equals 6 over 8 or 3/4. And then I still have 3 to find, but remember they're reciprocals of each other. So cosecant, which is the reciprocal of sine, is hypotenuse over opposite. So I would have 10 over 6 or 5/3. For secant, which is the reciprocal of cosine, I have secant of theta is hypotenuse over adjacent. So I have 10 over 8. Simplified is 5/4. And then finally, for cotangent, I have cotangent of theta is adjacent over the opposite, which is 8 over 6 or 4/3. So I have found, as requested, the length of the third side, which in this case was the hypotenuse, and I have found the values of all 6 trigonometric functions for that particular triangle. Okay, let's do another one. Use the Pythagorean theorem to find the length of the missing side, then the value of the 6 trigonometric functions. Again, be careful about the orientation. Here's my right angle. Okay, so the side opposite would be my hypotenuse. In this case, my hypotenuse is 25. My angle, which is my point of reference, is kind of in this top corner. So the side that measures 24 is opposite my angle, which is the point of reference. And I need to find the other leg. So again, using Pythagorean theorem, I'm going to do it over here down at the bottom. I would have a squared plus 24 squared equals 25 squared. So I have a squared equals, and I'm going to pull up my calculator because I don't know 24 squared. Let's see. 24 squared is 576. So I have a squared plus 576 equals 25 squared is 625. I then need to subtract 576 from either side. So I have a squared equals, and let's see, I'll pull my calculator back up. 625 minus 576 equals 49. So a squared is 49. If I take the square root of both sides, as I should, I find that a is 7. So the third side of my triangle measures 7, and with respect to my angle, that is the adjacent side. And so then we'll begin the process of finding our 6 trigonometric functions. So I would have the sine of theta is the opposite over the hypotenuse, which is 24 over 25, which is a fraction. However, that particular fraction does not simplify, so I just leave it alone. Then we have cosine. The cosine of theta is the adjacent over the hypotenuse, which is 7 over 25. Again, that particular fraction does not simplify. Then I have tangent. Tangent of theta is opposite over adjacent. So I have 24 over 7. And again, that particular fraction does not simplify, so I leave it alone. And remember then that, and it may help you to write these side by side, that the other 3 are the reciprocals of the first. So for sine, the reciprocal is cosecant. So the cosecant of theta is the hypotenuse over the opposite, or 25 over 24. The reciprocal of cosine is the secant. And so secant of theta is the hypotenuse over the adjacent, which is 25 over 7. Again, it doesn't simplify. And then finally, you have the cotangent, which is the reciprocal of tangent. cotangent of theta is adjacent over the opposite. So I would have 7 over 24. And there's your answers. Okay, now let's turn our attention to some applications of solving, for lack of a better term, word problems related to the right triangle trigonometric relationships. Okay, so let's look at this scenario. The safety label on a 12-foot ladder says the ladder should not be placed at an angle steeper than 65 degrees with the ground. What is the closest safe distance to the nearest foot between the base of the ladder and the wall? Okay, so the first thing I'll tell you to do in terms of applications is to read the problem. Okay, so we've read the problem, and then the second thing we want to do is maybe kind of sketch us a picture of what's going on. So we have a wall, and we're going to lean the ladder up against the wall. So here's our wall, okay, and we're going to lean the ladder against the wall. So here's our ladder, and then of course you have the ground. Now, once you've kind of got that basis, then you want to kind of think about what else you know. It says in the problem that you have a 12-foot ladder. So I know the length of the ladder is 12 feet. It also tells me that the ladder should not be at an angle steeper than 65 degrees with the ground. So that means the angle created between the ground and the ladder should be at most 65 degrees. And we want to know what's the safest distance to the nearest foot between the base of the wall and the ladder. So here's the wall, base of the wall, and here's the end of the ladder. And we want to know how far out we can lean the ladder. So this is our unknown. This is x. So then I have to think about what I know. I know that one angle, and I hope it's obvious. Maybe it's not to you, but it's obvious that the wall should create a right angle with the ground. Okay, so you have your right angle. So the ladder here represents my hypotenuse. Okay, so the ladder is my hypotenuse. My angle is this 65-degree angle. And then in this case, the ground represents the side adjacent to the angle. So I know the hypotenuse. I'm looking for the adjacent side. So I'm going to think about which trig function involves adjacent and hypotenuse. Now there really are two, because we could look at secant or we could look at cosine. If we have a choice, we tend to stick with either sine, cosine, or tangent. So I'm going to stick with the cosine of an angle is adjacent over hypotenuse. And using that formula or that trig relationship, I'm going to substitute in what I know. I know that my angle is 65 degrees. Okay, so I have the cosine of 65 degrees, that's my angle, is equal to, I don't know the adjacent side. Okay, so not knowing the adjacent side, that's my unknown or my x, over the hypotenuse, which is the 12. So I have kind of a good old basic equation. I'm trying to solve for x. In this scenario, to solve for x, I need to undo the division. And to undo the division, I'm going to multiply both sides by 12, so that I have 12 times the cosine of 65 degrees equals x. Now to solve that, guys, you're going to have to get your calculator out. And a couple of things as you begin thinking about using your calculator here. First thing you want to do is you want to make sure that your calculator is in degree mode. The measurement of the angle is in degrees. So I'm going to press the button on the calculator near the blue second button at the top that says mode. And on the third line down, it says radian or degree. Mine is currently set in radian, so I'm going to arrow down to the third line, then arrow to the right and highlight the word degree and press enter. My calculator is now in degree mode. So I'm going to quit. So second mode, and I quit. And then I'm going to type this in. You have buttons on your calculator face about 2 rows above the number keys that have sine, S-I-N, cosine, C-O-S, and tan, T-A-N. That's why we tend to stick with sine, cosine, or tangent, because we have buttons on the calculator that will do it for us. So I'm going to type pretty much what I have written here. 12 cosine, and then I'm going to enter the angle. And again, you got to have it in degree mode or you'll get the wrong answer. And I'm going to press enter. And so it gives me a value of x equals 5.07 if we round to 2 places. Now in the question, it asks us to round to the nearest foot. So to the nearest foot, I could have 5 feet between the wall and the end of the ladder and still be safe in using the ladder because I wouldn't have an angle more than 65 degrees. Okay. It's not necessarily a difficult process. It's just lengthy and you got to take your time. Let's look at another one. According to the American Disabilities Act accessibility guidelines, the maximum angle of a wheelchair ramp in new construction may not exceed 4.764 degrees. If a door to a building is 5 feet above the sidewalk level, how long must the ramp be in order to extend the sidewalk to extend from sidewalk to door? Okay, so again, we've read the question. Now we want to think about drawing a picture. So you have the sidewalk, and it tells me that 5 feet above the sidewalk is a door. Okay, and there's 5 feet. And so I've got to figure out how long a ramp I would have to install. Okay, here's my ramp. And my angle has to be no more than 4.764 degrees. Okay, so I'm looking for the length of the ramp. And again, I hope you realize that the sidewalk and this doorway would create a right angle. So across from the right angle is my hypotenuse, which in this case would be the ramp. With respect to my angle, I know the opposite side. The sidewalk would actually be the adjacent side. Okay, so I need to work with opposite, hypotenuse, and an angle. So if I think about the trig functions, and again, I primarily focus on sine, cosine, and tangent, I can use the sine of the angle is adjacent, or excuse me, not adjacent, is opposite over hypotenuse. Okay, so then I'm going to fill in, using that relationship, I'm going to fill in the information that I have from my description. So I would have the sine of 4.764 degrees is the opposite, which is 5, over the hypotenuse, which in our case is the x. And then I've got to solve that equation for x. Now, it's a little bit more involved, but it's good old basic algebra. I want to eliminate the fraction first off, so I'm going to multiply both sides by x. So I have x times the sine of 4.764 degrees equals 5. And again, remember, I'm trying to isolate the x. So to isolate the x, I'm then going to turn around and divide by the sine of 4.764 degrees. Divide by the sine of 4.764 degrees. So x is 5 divided by the sine of 4.764 degrees. And again, I'm going to go out to my calculator, and I've already confirmed that I'm in degree mode. So I would have 5 divided by sine 4.764, close it, enter. And so I get x is 60.203. So x is 60.02 feet. So roughly the ramp would have to be about 60 feet long, just a little bit more than 60 feet in order to be able to be long enough and at an appropriate angle for the American Disabilities Act. All right, one more. The angle of elevation to the top of a building in New York is found to be 9 degrees from the ground at a distance of 1 mile from the base of the building. Use this information and find the height of the building. Okay, so we have a building. Whoops, let me go back and get my pen here. We have a building. Here's my building. And it says if you go 1 mile from the building, okay, the angle to the top of the building then is 9 degrees. Okay, and we ultimately want to know how tall is the building. Now, typically buildings we don't think about in terms of miles, so I'm going to convert miles to feet. There are 5,280 feet. We usually think about buildings in terms of feet. So I know that 1 mile is 5,280 feet. Again, I have to assume that the building creates a right angle with the ground. Okay, so I have my point of reference looking at my angle, which is my point of reference. The building height is going to be the opposite side from the angle, and the 1 mile is the adjacent side. So I know some things about the opposite, I know some things about the adjacent, and I have an angle. And again, when I think of those 3 things in my mind, I think, oh, I can use tangent. That's why you need to become familiar with those relationships. So the tangent of an angle is the opposite over the adjacent. And so then I can plug in the information that I have. I have the tangent of 9 degrees is the opposite side, which is the piece that I'm looking for, over 5,280 feet. I'm going to do it in terms of feet rather than miles. And remember, my goal here is to solve for x. So I'm going to multiply both sides by 5,280. So I have 5,280 feet times the tangent of 9 degrees, and that equals x. Okay, I shut down my calculator, so let me go out real quick and get it so that I can show you how to do it. Sorry about that. Closed it out a little bit too early. Okay, so here we go. We want to do our calculations. So I'm going to type 5,280 tangent of 9. We already have it in degree mode. And we get 836.27. 836.27 feet. Okay, so roughly the building is 836 feet tall. Again, I put it in terms of feet because that's kind of the standard unit for measuring the heights of buildings. I hope you found these examples helpful, and keep watching.